Hello everybody, welcome to this video which describes my wireless rocket motor analyzer. Rocket motors are inherently dangerous to design and can sometimes explode violently. We try hard to ensure that rocket motors do not do this inside our expensive rockets. To that end, we static test motors to verify their design and performance. We like to do this away from people and property, so if something goes wrong, all is still okay. We also like to obtain lots of data on the motors so that when we go to put them in expensive rockets, that they do what they are supposed to and fly our creation skyward. To that end, I constructed my wireless rocket motor analyzer. It has a wooden construction with a sturdy base and even wheels to make transport easier. The motor thrusts down onto a load cell, which measures the thrust. It also is capable of recording chamber pressure if that is required as well. The electronics of the project consist of load cells, a microcontroller, load cell amplifier, wireless transceiver, remote ignition circuitry, and a battery. The PCB is all hand-soldered jumpers at the moment, but could easily be constructed on a PCB. I'm making use of my 70cm wireless serial bridge, which is a neat project in and of itself. It converts data coming over the transceiver link and converts it to a telnet session over Wi-Fi for easy access for my cell phone. It has the added benefit of having an LCD which can be written to by projects on the 70cm mesh network. It consists of an LCD panel, ESP8266 Wi-Fi microcontroller, transceiver, and a 7805 regulator with filtering capacitors. In the field, I connect a 6-element Yagi UDA antenna and can attach my USB SDR dongle for spectrum viewing or direction finding of my rockets. When powering up the 70cm Wi-Fi serial bridge, I get a nice initialization screen, followed by some status updates when it connects to my phone over Wi-Fi. At this time, I simply start a telnet session on my phone and type START to initialize the bridge to the last configured settings. It updates the screen letting me know it is now in a transparent serial bridge mode to my telnet session. I can now haul my wireless test stand out to up to a half mile away from me and load the motor and power on the test stand. Back on the 70cm serial Wi-Fi bridge, the LCD updates, letting me know the electronics are booting. The system proceeds to calibrate the load cell and pressure transducer, removing the tare weight of the rocket and displaying the noise level of the load cell. Since the stand is capable of wireless remote ignition of rocket motors, the stand must be armed before use for safety. On my cell phone's telnet session, I enter the arming command and code, and the system arms. At this point, I can remotely ignite the motor upon command, or if in a club setting, the rocket motor may be ignited by club electronics. The test stand will continuously monitor the thrust and chamber pressure for the signs of ignition. Once it has ignited, the LCD screen tells me it has detected the ignition. I wait until motor burnout, and the screen updates again. It displays my burn time in seconds, and then gives me motor specifics in newtons instantly right after the burn. Some systems require you to do all the analysis later, after the sample data is inserted into a spreadsheet on a computer, but my system does all the math on board right after the motor finishes its burn. I can then wirelessly request the thrust curve, and over the serial link, the unit will give me the thrust and pressure data over the burn time with millisecond timestamps. I can use this data to later make graphs and manipulate the data how I feel fit. This project has allowed me greater confidence in motor design while simultaneously being easy to operate. Easy operation ensures that launch day stresses are at a minimum, and I can ensure focus on the hobby instead of the technology. Thank you so much for watching this video. I'm planning on doing a few others in this format in the future, so stay tuned. If you have questions or comments, please feel free to post them. And be sure to view my Hackaday projects page or go to www.jeffmhopkins.xyz. Thank you.